Hi everyone. I wanted to show you a library I came across which makes code generation in C much easier. The library is called Metadesk. It's written by Ryan Fleury, who is also working on the RAD debugger, which we'll be using in the video as well. To start, I'm going to create an input file which Metadesk will read in. Metadesk accepts a superset of JSON, so I'm just going to start with plain JSON. So something like that is perfectly valid in Metadesk. Now let's create the main file which will read this in. First, I'll just include the header file and the C file for Metadesk. Metadesk uses arenas for memory management. I won't go into how arenas work in this video, but I will link in the description a great explainer on arenas featuring Ryan himself. So I'll declare an arena variable here at the top. And then in my main function, I will allocate that arena. Now, I'll pass in a file name as the first argument to this function. And so the first thing I'm going to do is convert this to a string 8, which is what the library uses. Now, this is just the raw pointer along with the size. So I can do file name, and then I can do mds8 cstring as a helper function, and then we can parse it. Now we do need to allocate some memory for this operation. Anytime you need memory, just pass in the arena as the first argument. Now if I write a little build script, and a little run script, which just takes that executable and passes in the input, then we can build that and check it out in the debugger. So I'm just going to add that run script we just wrote, turn on debug subprocesses, and then I'll also open the main function we just wrote. So within this result object, there's a node. That node represents the whole file. And then it's got standard tree pointers to its next and previous sibling. In this case, they're just empty nodes. And then it's got pointers to the first and last child. So the first child is that outer object, and it's got a first child, which is the first key. And then this also has a first child, which should be the value. So Metadesk is very flexible, so we can do different versions of that input. So I can, replace these with brackets. I could remove the quotes around everything, and this will essentially give the same result. The only difference is that before, raw string included the quotes, but now that we got rid of that, string and raw string match. So that's an overview of how the input format and the parser works. And now let's actually use this to do some code generation. So one thing I'm interested in is parsing C code. And I would like to have an enum for this certain kind of keyword that you can put in a declaration called a storage class specifier. So if I just copy this and put this directly in the input, this is also valid Metadesk input. And then I can go back to our main file, and I'll grab that file level node, That's going to be result.node. And then directly under this file are now all those keywords that we listed. So we can iterate through those using this handy macro md each node, where we pass in the variable name we want to use. I'll do item node, and then we pass in the first node we want to start iterating with. That would be file node first child. And now let's just print out all the strings. So I can print f, and I can use this trick which basically says that we'll give it a pointer and a size, and we just want to print out the length of that. And then to unpack the string 8 into the pointer and the size, I can do md s8varg, and I can pass in item node string. So now if we build this, forgot to close our for loop, build this, and if we run that and check the output, we have all of these tokens printing out. Okay, so now let's go back to our input format, and I'm going to add some elements here. So I'm going to wrap these in braces, and what this is doing in the format is it's basically creating an unnamed node which now contains all of these. But I want to give that node a name. I'll do storage class specifier, and then I'll add a colon which lets the parser know this is part of this next node. And now we've got this additional object node that we want to unpack. So that would be file node first child. And now if I go over the object node and print it all out, that should do the same thing. So let's just confirm that that works. And run it in the debugger. Oh, because it's stopping there, we need to move that down. And yeah, here we've got all our output. So now let's make this look more like an enum. So instead of just printing everything out line by line, I'm going to put them in a list and add some formatting in like a join, much like you might do in, say, Python. So I'm going to create a list, md string 8 list. This can be enum list. I'll initialize that to 0. And then in the loop, instead of printing it out, let's add it onto the list. So we'll go md s8 list push. We need memory for this operation, so we pass in the arena. We pass in a pointer to the list, and then we pass in the new string we want, item node string. And now we can concatenate these all together. We can do md string 8 joined equals md s8 list join mid. There's another version of this function without the mid part, which also lets you specify a prefix and a suffix. But in this case, we just need the joiner in between the nodes, and we'll pass in the arena, of course. We'll pass in the enum list, and we'll pass in a separator, S8 literal, and let's do a comma and a new line. And then let's print out joined. And now if we run this, we should get everything printed out with the commas added. So we're inching closer to an enum here. Now let's do some more formatting in here. So we know that this object node has a string, which is the name of the enum. So we can unpack that. md node let's go, or actually, MD string 8 enum name, and this would be the object node string. And now we can actually format this name in different ways. So I'm going to also create another string 8, enum name cap, and I'll use one of the stylize options. So I'll do MD_S8 stylize. I'll pass in the arena because this needs to allocate a new string. I will pass in the string we want to style, and I'll pass in this MD identifier style enum, and I'll pass in the uppercase version. And then I'll pass in basically when it identifies different parts of the token, what separator do we want to put in? And so I'll do MD_S8 literal with an underscore there. And so in this loop, I want to take that capitalized version and use it as the enum prefix. So I'm going to do something like this. I will first capitalize each of these items coming in. So I'll go MD string 8 and basically do the same thing. So this will be item cap, and this will basically use the same function here, but we just want to do item node string here, and everything else should be the same. So we have our item cap, and now we want to concatenate this together with the enum name cap. So I can do a modified version of the list push format, and then here I can pass in format string. So I want the prefix followed by an underscore followed by the prefix. And while we're at it, we can just add an indent here. And then I will pass in both the enum name cap and the item cap. So I'll do the enum name cap and then the item cap. And now, if we print all these out, they should look like properly formatted enum items. So we just move our breakpoint down. And sure enough, we get our prefix followed by the item that we wanted. So now let's just wrap up an enum definition. So instead of just printing the items here, I'm going to do something like this, type def enum, and I'll pass in the name, and then I will pass in the name again, colon, new line, and then I'll go enum, pass in the name one more time, new line, pass in our opening bracket with the new line, pass in the items there, and then I'll do one more for the count. So I guess I can do something like this. So that will, I'll use the prefix there, and then I'll just go underscore count. I think this needs a comma and a new line, and this needs just the new line. And then we can go closing bracket, semicolon, new line to finish it off. And then we need to modify the args. So we need MD_S8V arg for the enum name. And I think we need that 3 times, right? 2 for the type def, 1 for the enum itself. So we can pass those in. And then we can pass in our join string there. And then we can pass in the capitalized one, enum name cap. And that should be a proper enum declaration. So let's see how we did. Move this down, run this. And let's see, type def enum, storage class specifier, enum, storage class specifier. And we've got all our items, all with commas except the last one. Looks good to me. So far we've generated some valid C code, but the real power of code generation is when we can generate multiple declarations for the same Metadesk object. So now I want to introduce one more concept in Metadesk, which are tags. So let's say we have this definition, but we want to then tell the program that we want to generate an enum for it. So we can go at enum, and this is just going to, for that storage class specifier node, it's going to add on a first tag, and we can add multiple tags. But for now, let's just modify our main function. And all I want it to do is first check whether there's an enum tag, and then decide if it should generate the enum. So let's do something like this. We can go for MD each node. I'll take that, I'll call this tag node now. I'll take that same object node first child. And then I'll say if MD S8 match, and I'll pass in the tag node string. And then I'll do an MD S8 literal for an enum. And then in this block, we will actually generate the enum. So let's maybe bring out that enum generation to its own function. So we can go void generate enum. And let's just have it all run on the node. So we can do MD node. Let's call this like enum node. And so I'm going to actually generate these names in this function. So this will be the enum node string, and then we'll say that the capitalized version is the enum name capitalized. So that looks good, and then starting from here, I can just grab this code and bring it up into our function. And then if I did everything right, I should just be able to call that function, generate enum here, and pass in the object node. And then I need to close the brace there, and the rest looks good. So let's see if we did that right. Let's see, struct or union, file node first child, object node first child, object node, enum node, enum nodes, oh, object node. Forgot to rename that. Let's see, do we have it anywhere else? Okay, I think we got it all. S8 match also needs a flag. So we'll pass in that flag there. And then that builds, and let's just see if we get the same output. So we didn't actually get the output. Let's see if we hit this. No, we didn't. Let's see what's going on there. So we've got the string here, which is tag node, object first child. Oh. Yeah, we need to do, instead of first child, we need to do first tag here. So let's build that. And now we should hit this and enter that if statement. And now the output should be good. Let's just confirm that. Yes, that looks good. Okay, So now let's extend this to also create a list of the names. So I'm going to edit the input format, and I'm going to add a tag for names. And then I'm going to add another block here, if MD_S8 match, tag node string MD_S8 literal names, pass in that flag. Then we can generate names. And let's just start by grabbing the same function and popping it in here, generate names. So let's have this, instead of the enum name, now we want probably the variable name. And this variable name, we should, the node name, the enum node, we'll change that to name, well, I'll call this maybe variable node. Okay, so that name is actually a Pascal case, and so we will stylize this to make it lowercase. So here I'm just going to go lowercase here, and using the separator should give us some nice snake case, nice snake case var name. So now this can be var list, and we can still go item node. We don't need the capitalized one. In fact, all we don't need any of this. We can still push format, but all we actually need is the indent along with the name. And the only difference here is I'm going to use the item node's raw string, because this will keep the quotes that we want. So this is still enum node. We need this to be var node. And then we can again join those. We still want the comma in the new line. And now here we just want char pointer. This can do the var name, and we want brackets here and the equals sign, and then our new line. And then we can have our opening brace, a new line, and then our items, and we don't need a count here, and then our closing brace. So what we need here is the var name, of course. We need the join string, and we don't need anything here. So do I have any enum stuff here? Let's see, here's my generate enum. Generate names. Let's get rid of that. So we need var node string here. And here we need the var list. And here we also need the var list. I could have named these something more generic so we wouldn't have to change names around, but this works for the demonstration. Okay, let's see how we did there. We just need to end the debug process. And let's drop this down to the end and run. So I'm seeing our enum, and I'm seeing char pointer storage class specifier. I don't see the quotes around it. Oh, because we actually never had quotes in the input. So let's just correct that there. So let's do W plus here, and then go quote item. So now that should actually work with everything else the same. All right, yeah, so our enum, since our enum used the string, it doesn't get the quotes, but since here we use the raw string, we get the quotes. So hopefully that provides a good introduction to Metadesk. You can take it so much farther than we did in the video, so I encourage you to check out the library and try your hand at some code generation. Thanks for watching. See you next time.